Hi, I'm making the video for 6.5. 6.5 is on the common log and the natural log and how to use your calculator with those things. And so actually the way the guy has the book set up, that you don't use your calculator at all until this section. And but I know that I've been showing you how to use your calculator, and many of you have calculators that have any log, not just the common log and not just the natural log. So we're going to look at it, and this might not be a section that tells you very much if you've been using already just the regular log on your calculator. Okay, but I'll go ahead and I'll show you. So log base 10, and I think I can scoot in just a little bit. Well, a little bit too much. There we go. So log base 10 of x is the same as log of x. So they don't write the 10, and when they don't write the 10, it's assumed to be base 10. So if I want it to be base 3, then I have to write the 3, log base 3 of x. If I want it to be log base 5, I have to write the 5, and maybe I have a number like 27. So that's not going to be a particularly nice value, but it is a value that that I can put in my calculator and find. So when they don't put anything, when they just put log, it's assumed to be log base 10. Then there's two common logs, and the other one is called natural log. And the natural log is log base e. And I don't know if you guys remember that number e. It's 2.71828. It's Euler's number, and it goes on forever, and it has more practical applications than pi. And so it's a really common logarithm, and it's called the natural log. And log base e of x. Now they couldn't just use log, because if they used log, that meant log base 10. And so instead of, if it was English speaking people that came up with it, I'm sure they would have called it NL for natural log. And, but it was non-English speaking people, so they call it log naturel is what they call it. So that's why the L, so that right there is, so it's LN is what it is, and usually lowercase l, so LN. And so that's log base e. So we're going to do some examples. They're asking us to use our calculator and find the following and round to 4 decimal places. That's good. We'll get to practice our rounding to 4 decimal places. So I have two calculators here going. I don't have a TI. I have a TI at school, of course, but not here at home. And so when I want to do log base 2, right, this calculator right here has the log key, and that's log base 10. And so I can put log and then hit 2, and then you can, it put the parenthesis in. So log, and it put the parenthesis in for the input. And when I hit equals, it gives 0.301029995. That's what, it's what it has. Now it's said to 4 decimal places. So I'm going to write this out here. So 0.3010 is 4 decimal places. The next number was a 2. And since that number is not over 5, you would just call it good, 3.3010. And you can put the leading zero there. On this calculator here that I have, it doesn't have the just LOG button. And so if I want to do LOG, then I have to hit this button here that says any base, and I have to put in 10 is what I have to put in. Because LOG means log base 10 of 2. And you notice I get the same value. 0.3010. So on this calculator, I had to know that log without anything is base 10. On this calculator, I can just see, oh, it has all three logs. It has any base log, log base 10, log base E. This one only has any base log and log base E. It doesn't have the log base 10. I don't know why. It doesn't have the log base 10. It doesn't. And so, and then the next one here is log of -2. So I'm going to clear this out and I'm going to hit log, and then I'm going to put in the -2. I'm getting text. And when I do, it gives me error. If you're asking, well, why did it give you error? I hope that you're remembering that the input into a logarithm has to be positive. That was one of the things that they told us. Also, the base has to be the base. I'm going to call it B. The base. I'm going to call it base. Has to be greater than 0, and the base cannot be equal to 1. So those are some things that we know about it. And so I'm not surprised that it gave me error because the input into the logarithm has to be positive. So this gave me error, and I'm not surprised that it did. Okay. Now this is asking me to find log base 10 of 5,700 divided by log base 10 of 5. And so when I go to put that in my calculator, I can use the fraction key and do log and base 5,700. Now you have to close the parenthesis, and so I know that there aren't parentheses here, but they're implied parentheses right here. And the calculator wants to make sure what you're thinking the input is. And then I'm going to go downstairs and I'm going to do log base 5. And I'm going to close that parenthesis that's there. And when I do, my calculator is giving me 5.3734. And then the next number is a 4. So because it's not 5 or bigger, then we just truncate. And so 5.3734 is our answer. I want you to notice that log of 5,700 divided by 5 is a different answer. And so it looks different, right? This is the whole input now. And so, but I'll do that so that you can see you get a different answer. So log and then 5,700. And whoops, I wanted to do the fraction key and I forgot to, so I had to back up. 5,700 and then downstairs 5. And I don't expect that I would get the same value, and I don't. I get, for this, I get 3.0569, and the next number is a 0. So since it's not over 5, you truncate there. Just coincidence, I didn't have to round any of them up. Then the other example here, example 4, is using your calculator to find 10 raised to the -3.2046. Before you put in your calculator, do you expect to get a math error? I guess that's what I'll ask you there. And so you might say, yes, I do expect, because it's not supposed to be negative. But actually, this is the exponent on the exponential function. And the exponent can be anything. And so the exponent is allowed to be anything. So I'm not expecting to get a math error. So recall the input of the exponential function can be, this is what we're putting into the exponential function. That's its exponent, and that can be any real number. And so here we go. 10 raised to, so I'm doing 10 raised to, and then the -3.2046. And my calculator went into scientific notation. So my calculator gave me in scientific notation 6.24309, so that's going to be 1, right? times 10 to the negative 4. So my calculator is giving me 6.2431 times 10 to the negative 4. And so this is a really small number. And so, oh, I was asking you, do you expect a math error? And we said no, because the exponent was okay. Do you expect a large number or a small number? And 10 raised to the negative power is going to be a really small number. And did I expect it to be positive? And yeah, I expected it to be positive. I didn't expect it to be negative. 10 raised to any power is a positive value. And so even though, now remember what this means. It means move the decimal 4 places. So this is the decimal here, 6.2431, right? Move it 1 place, move it 2 places, 3 places, 4 places. So this is moving the decimal 4 places. So this would be 0.000624431, right? And my calculator probably would have given it to me in regular notation, but I don't know, maybe your calculator did give it to you in regular notation. My calculator gave it to me in scientific notation. I wonder what this one would do. It depends on what settings you have it in. 10 raised to the negative 3.2046. It also gave me it in scientific notation. If I choose to go here to menu mode 1, no, it's setup. Setup and normal number 2. And then try it again. 10 raised to the negative 3.2046. And then my calculator gave it to me in regular notation. And so it's crazy, but under shift and setup, under normal, there's normal number 1, which typically gives it to you in scientific notation. And there's normal number 2, shift, and normal 8, number 2, that gives it in regular notation. And so I don't know how you're supposed to know that, but that's what happens there. Okay, so again, this is practicing using our calculator. Okay. So here it's asking us to use our calculator and round to 4 decimal places. And it has the natural log of 1900 divided by 0.07. So our calculator has natural log on it. So here's the natural log key right there. And I want fraction. And so natural log 1900 in the, you have to end the, put the parenthesis, it put the beginning, so I have to put the end. And then I want to divide that by 0.07. And I'll hit equals. And the calculator gives me, it says to round to 4 places. And so 1.07. And then here's where we're going to count the places. 8, 5, 1, 5, 5. And so here is 1 place, 2 place, 3 place, 4 place. So I want, and this number here is bigger than 5. So we're going to bounce that up. So this is going to be 1.07, 8516. So this is going to round up, right, to 6 when we get rid of that place. The next one is asking me to find E. We had found E on your calculator. I remember in class I was running around helping people find E. There are 2 E's on your calculator. There is an E at the bottom of this calculator. Right here, next to the pi is E. And if I want to use that one, I can. It's in red, so I have to hit alpha and then hit it, and then it comes on my screen E. And then if I want to use the raise to key, I can raise to, and it says to raise it to the negative 2.64. So this is one way of doing it. And so this is equal to 0.0713 3, the next number is a 6, and because 4 places, 1, 2, 3, 4, the last number should be 3, and because this is a 6, we're going to bump that up to a 4. So 0.0714 would be when we round it to 4 places, like they said. Okay, so the other way that you can put this in your calculator is right behind the natural log button, because remember, natural log was base E. Right behind the natural log button is E. Do you see it there? And it is in orange in this case. So when I clear and I hit Shift and I hit the natural log key, I get E raised to, and it already puts the raised to there for me. And I just put in the negative 2.64. It's not going to give me a different value just because I did it a different way. And so it's going to give me the same value. And anyway, so that's kind of that story right there. This calculator here works exactly the same. And so it is the alpha and there, and it's also the shift and here. And it gives you exactly the same. And so e to the, and then negative 2.64. And it gives me the same value. And so then the last thing, and then I think I'll get my book and make sure that I have done all of the types of homework problems of every type there, because it seems really short. But it says the function y at x equals 21.77 natural log of x over 5.5 can be used to estimate the number of years, y stands for years, after 1982, required for the world's humpback whale population to reach X thousand whales. In what year will the whale population reach 15,000 whales? So remember, this was X thousand whales. And so Wells is not spelled right there, sorry. So in this case, this is 15,000. So what they're saying that X is 15. So in order to use this formula, you have to change 15,000 for 15,000 wells into just 15, because this formula says that X is just in thousands. So if I want to know what year there will be 15,000 wells, then X at 15, this is what year, this will be the year that there are 15,000 wells, equals 21.77. The natural log of X is 15 over 5.5. And then I'm just going to put that in my calculator and hit equals. And that will tell me the year that there is going to be. Oh, and this will be number of years after 1982. So this will be a number of years, and then we'll have to add it to 1982. Okay, so 21.77, the natural log. So I hit the natural log, and then I wanted a fraction, 15 divided by 5.5. And we get 21.8. And this is a number of years. And so would you agree with me that this is around 22 years? And so I'm going to put about 22 years. So that's when the humpback whale population will come back to 15,000 whales worldwide. So in 1982, and plus about 22 years, will be in 2004. So in 2004, there'll be around 15,000 whales. Then it's wanting us to use the model to approximate how many wells there are now. So from right now, it's 2022. And if we take away 1982, that will be 40 years. So what we're wanting our Y to be 40 years. And so the number of years we're wanting, and 15 is how many wells there are, so we don't know how many there are. So we're wanting our Y, I'm going to say Y at X equals 21.77, the natural log of X over 5.5, right? And I'm going to just call this Y, the number of years, 40. And it's a approximate. Now, natural log is log base E, and we have too many numbers here. I want to show you that we have too many numbers, because what we know how to work with are things that look like this. It can be a number you could call it the input. Then you have the log, and the log has a base. And in fact, this was called the exponent, not the input, sorry. Exponent and the input. And so do you guys notice that I have one more, I'm going to write the log, the natural log as log base E, and I have one more thing that I'm allowed. I'll show you which one is the one that's not allowed. So this is log base E, and this is my input, X over 5.5. So the natural log is the same as log base E. And what's not allowed is a coefficient right here in front of your logarithm. The 21.77 is what's extra. The input is X divided by 5.5. So that's okay. The base is E, and that's okay. And the exponent is 40, and that's okay. So what's not allowed is the 21.77. So we want to get rid of it. It won't be helpful to take away 21.77 because it's not added with a logarithm. It's multiplied by the logarithm. So you have to do the inverse of multiply, which is divide. So I'm going to have to divide. I'm going to run out of room here. 21.77. And here too, 21.77. And so this is going to give over here 40 divided by 21.77. So 40 divided by 21.77. My calculator is giving me that big O value, 1.8373900905. I'm not going to round, equals log base E of X over 5.5. And I want to solve for X. And so now is where I'm going to use my property of logarithm, and I'm going to write this in exponential form. And so the base, remember how when you go to write it in exponential form, you write down the base, you write the exponent equals your input. So when I do that, my base is E raised to my exponent. My exponent is this big O number here, 1.8373900905 equals X over 5.5. And now I can solve for X. I'm going to erase this part down here because I'm just running out of room. So I've changed it from being in logarithm form to being in exponential form. And all I have to do to solve it is multiply by 5.5 because that's what X is being divided by. So I can multiply both sides of the equation by 5.5. So this is going to be 5.5 multiplied by E to the 1.8373900905 equals X. And because 5.5 divided by 5.5 is X, and X is the number of wells there are in the year 40 years after 1982, which is the year 2022. Okay, so 5.5 times and then E. So I'm going to do my shift and then E. So times E raised to the 1.837390905, and I get 34.54, right? It goes on, equals X. And remember, this is in thousands of wells. So this is 34, I'm going to say 0.5 times 1,000 wells. So this one had some units going, huh? So times 1,000, and this will be how many wells, which is 34540. I don't know, 0.7. I'm going to go ahead and go one more well there. They didn't tell me where to round here, and so I'm going to be as accurate as I can. So this is and the one more well, somebody's baby, and so it's important. An important well, right? This was ... and I just multiplied by 1,000. So we did a lovely job on that. I'm going to see about grabbing my book and making sure that I have done on 6.5. Is this 6.5? It is. On 6.5 that I have kind of done all the types of problems that I assigned. I remember it just sort of being, I'm in chapter 5, 6.2, 6.4. Okay, so I'm putting my book under here so that you can make sure that we've done all these types. So just doing pushing in log, right? The log base 10 key, and give our answer to 4 decimal places. We practiced that. Oh, I didn't practice any of these. So let's try some of them. I don't know why I didn't have any of those on my sheet. So we're going to try a few of them. I'm going to write on the back here. Okay, so this is off of 6.5, and I want to just do a few of these problems. This would have been better if I would have done some of these. So this is 22. This is log base 10, right? Equals 4.8802. And so I'm going to put the 10 here. And then what you do is, I guess we had done these in the last section. That's probably what I was thinking at the time when I made those notes. So this is, remember, we want to write it in exponential form. And so let's see, this is log, the base, and the input equals the exponent. And then in exponential form, this would be the base raised to the exponent equals the input. It's a matter of rearranging the furniture, right? And so our base here is 10. Our exponent is 4.8802, and that equals X. And then we solve for X, right? And so they asked us to find X, express answer to 3 significant digits where appropriate. Okay, so here, 10 raised to the 4.8802. And then we're going to take this to 3 digits. Are they wanting? I'm going to look in the back of the book. I think what they're wanting is 7592.6993. So the 3 is in the 4th place. And since they said 3 places, I'm going to go with that's what they're wanting. That's not exactly what they've said, though, on significant digits. But that is what they are putting. And so in the back of the book. And you want to try another one? Okay, we will. Let's try 34. Log base x equals 10. Do you guys notice that it's the same problem? Because it says log, that means the base 10. And then we would write this in exponential form. So this is 10 raised to the 10 equals x. And that's a really big number, 10 to the 10. I'm going to just have to leave it here. My calculator is not going to handle something that big. 10 raised to the 10 is going to be, it's going to go into scientific notation. 1 times 10 to the 10. So 10 to the 10 and 1 times 10 to the 10 are the same. It's just such a big number that my calculator won't handle it. Let's try, I want to do a negative one. So this is 41. Natural log of x equals -1. Now, what natural log is base e. So this is log base e of x equals -1. And then now I can write it in the notation, right? The base is e. The exponent is -1, right? So this is e to the -1 equals x. And so there's my exact answer. And then I'm going to find it to 3 digits like they were asking. So this is E. So this is shift and to do the E. And then I want -1. And so I get 0.36. So this is 0.36. They said 7, 8, right? And they said to take it to 3 places were the directions. The directions had been 4 places, and now these directions are 3 places. So equals x. So at 4 places, this 8 is going to go away, and we're going to move that up to an 8. So 0.368 would be our value for x. So these are problems right out of your textbook that I'm doing. And I noticed that they have some that this is number 43. It's log base x of 2 log 5 is what it looks like. And so we'll give a try to doing it. I don't know if you remember the property that we learned yesterday. And so there's more than one way of doing this problem, and I'll show you both ways. One way is to use that property that says that if you have a product, that you can move that product to the exponent on your logarithm. So this is log base 5 to the second. And so that 5 to the second is 25. And so what we had over here was we had log base x just coming down. And then now look at what we have. On both sides, we have log base 10. And both are base 10. And so x must be 25. So that's one way of doing this problem. And that was to use the property that said that if you have a multiplication, that it can become an exponent on your logarithm. Now, the other way of doing this problem would have been, so this is an or, log base 10, I'm going to put the 10 there, equals 2 log of base 10 of 5. It would have been to use your calculator, okay, and 2 log, right, of 5. Now, this is not going to be a nice value. So there it is, 1.39, etc. 397940009. I don't want to round. And this is log base 10 of x. So I just put that in my calculator. And now I'm saying, well, if I wrote it in exponential form, the base is 10. The exponent is 1.397940009. And in fact, that base was 2 log base 10 of 5, right, is what it is. I'll try it both ways. Equals x, right? That's what this was equal to, equals x. So when I try it here, 10, might get some rounding error. 10 raised to 1.397941239. It pretty much gives me 25, which we knew the answer was. Now, when I do it exact, right? Let's try it. You notice that almost gave me 25. So if I do 10 and then raise to 2 times log 5. So I just put that in my calculator. 10 raised to 2 times log 5 equals, and it gives me exactly 25. So I guess there's 3 ways there of doing it. One involved a bunch of rounding and the other did not. Hello, my friend. I'm making a video for my algebra class. And so our class starts in 10 minutes. And so I'm on this computer making the video for my algebra class. And I think I'm done with it. I think that's all of the problems that I assigned any like. And the well one, oh, there's the well one. Yeah. Okay. And so I think that's the end of this video. And so I will see you guys in the next video. Bye-bye.